The last reaction of this chapter 10 is the reaction that makes use of the so-called Gilman reagent. The Gilman reagent, it has two alkyl or alkenyl or aryl groups attached to a copper atom, and that part of the molecule will have as a counterion a lithium plus. And so you have a negative charge on the copper. Well, so let's see first, how can we generate a Gilman reagent? You can react a compound like a 1-bromobutane. You react that with two equivalents of lithium. Obviously, you run this reaction in a solvent that is non-protic, like a pentane. And in that way, you form butyl lithium and lithium bromide. Lithium bromide is a salt that will precipitate, and we don't care too much about that. We are more interested in the organic portion of the molecule. Here, I give you another example on top. Here, I am using two equivalents of methyl bromide reacting with two equivalents of lithium. And in that way, I'm sorry, I didn't need two equivalents of this. You don't need two equivalents of the methyl bromide, just one equivalent of methyl bromide and two equivalents of lithium. And that will give me one equivalent of methyl lithium and one equivalent of lithium bromide that will precipitate. Then, once I had prepared my alkyl lithium, I can go to the next step of the reaction. You use two equivalents of the alkyl lithium to react with copper iodide. Again, you make use of a solvent that is non-protic, like ether, and in that way you form your so-called Gilman reagent. Let me illustrate this with a different molecule. So I will repeat the same sequence of steps, but with a different molecule. So let's say that I start with this compound here. So this is a primary bromide. I will have to use two equivalents of lithium, and that will form the alkyl lithium plus lithium bromide. I'm not interested in this. And then I can use two equivalents of my alkyl lithium. There, I'm using the two equivalents of this with copper iodide. And in that way, I form my so-called Gilman reagent. Gilman reagent. This is the Gilman reagent. So there you can see that the copper is bearing a negative charge. You have two alkyl groups attached, two alkyl groups that they are identical. And then we have a lithium cation as a counterion of the anion. Another way to write down this same structure here is by making use of brackets and parentheses. I can say I have a copper that is attached to 2 units of whatever I have in the parentheses, right? 2 units of that. So here I have A, B, C, D, E, let's say. So and then here I'm repeating A, B, C, D, E. So 2 units of that, of whatever is in the parentheses, and then everything in brackets, and I can put my negative charge out, and in that way I am not specifying who is bearing the negative charge. We know that is the copper anyway. And then once you have formed your so-called Gilman reagent, Then now you can react that with any other alkyl halide or aryl halide, and whatever was in the parentheses here will get attached, will get replaced, and will replace the group that you had attached to the halogen in that alkyl halide. And so here is this carbon atom with a star. That carbon atom was in the original benzyl bromide. That is still there, right? Still there. And then now I attach A, B, C, D, E, and that will be my final product. So that is pretty cool, right? Because that is a much more complex looking molecule. And we were able to do that by using the methodology of a Gilman reaction. So one challenge for you: how can you synthesize this final product starting only with cyclohexane and 2,2-dimethyl propane? How could you do that? Huh? And you can use any other inorganic materials that you want. So what I could do, just very quickly, what I could do, I will transform my cyclohexane. I will react that with bromine and light, and I will make that into bromocyclohexane. Then I can react my 2,2-dimethyl propane with bromine and light, and I will form this, right? Then I can make the Gilman out of this. You know how to make the Gilman there, so you will end up with lithium plus copper, and then you will have in parentheses here the 2 cyclohexyl groups, and all these will be negative. And then I can react this guy here, the Gilman, with my halide that I have there, and these two guys together will give me the final product. Huh? Not bad, huh?